All right, picking up where the last video left off, we'll quickly talk about example 2 and 3. All right, so example 2, it says write a linear function that corresponds to the following arithmetic sequence. So first thing that you should notice is that this one is decreasing as we move forward. Does that change the way we do the formula? Not at all. So still a sub n equals a sub 1 plus, and I'm going to put the d out front just because that's where I prefer to put my distributive property. Again, on your formula sheet, the d is listed behind the n minus 1, but it means the same thing. All right, so this is basically your slope, right? It's your common difference. It's the thing you're repeatedly adding or subtracting by. And this is, of course, the first term, not the y-intercept, right? If you're graphing this, this would not be your y-intercept because it's the first term, not the zero term. And again, that's the reason why you have this n minus 1 instead of just having n, okay? So this would be what? Let's see here. A1, it's pretty easy, 8, okay? Plus, we'll have to figure out what the common difference is, and then n minus 1. How do I find the common difference? D equals any two consecutive integers subtracted. So A2 minus A1, or A3 minus A2, or A4 minus A3. You always do the second term that you pick two consecutive ones, you take the second one minus the first one, okay? The people that are going to miss this are going to do this backwards. Okay, so make sure you're paying attention to that. It's always the last one minus the previous one. All right, so in our example, we're just going to do A2 and A1, so that would be 1 minus 8. Some of you are going to make the mistake of calling that 7 because you think it can't be negative. But as you see, it's going down, so it is. So plus negative 7. Now, I don't particularly care for the way that looks because I don't want to have this plus negative, so we're going to change it to make sense. So it's 8 minus 7 times n minus 1. Okay? I did not need to put it in there, my bad. There we go. Minus 7, parentheses, n minus 1. Sorry about that. So now I have my explicit formula. So if I want to find a specific term in that sequence, I can multiply, I can plug in that number and subtract 1, then multiply by 7, and then do 8 minus whatever that number is. Okay? Now, one thing I do want to talk about, we mentioned it before, I could change this to a function notation, and it would look like this. Okay? Now, the reason I did that is because sometimes you'll see someone, they'll give you a sequence, and they'll give you the pattern like this, and it'll be multiple choice, and you'll look, and this, all the answer choices will be in function notation, but this right here, the 8 minus 7x minus 1, won't be an answer choice. Okay? The reason is because if they go to function notation, you have the ability as a student to simplify this, right? We can clean that up because we know how to use distributive property. So all of a sudden, this becomes f of x equals 8 minus 7x, because we're distributing, plus 7. All right, and what this does is we can simplify this using our order of operations and combine those two, which means this is going to be 15 minus 7x, or you might even see negative 7x plus 15, which should stand out to you because that is in slope-intercept form. And if you really will think about it, if this is A1, then this is A2, well, what would our initial value be? What would our A0 be? Well, if I went 7 in the other direction, that should be 15. So this is actually A sub 0, which means I no longer need the x minus 1 here. I can just use x. And then this, of course, is the same. That's our common difference, the slope, right? So basically, we've taken it back from this explicit sequence formula, right? The explicit formula for sequence, to a generic y equals mx plus b. They are connected. They mean the same thing. So don't think that they're unrelated, because they're not. The biggest difference between these is just the way you write them, and it's because you're given the first term as opposed to given the y-intercept value. Okay? That's the whole idea here. And also understand that your domain on these sequences is restricted to x equals 1, x equals 2, x equals 3, x equals 4, positive consecutive integers. Okay? All right, good. Let's move on to the last example. So example 3, an arithmetic sequence is defined recursively. So here's that recursive formula. This is the other one. And all a recursive formula does, it's really simple. Don't overthink it. It relates any term in a sequence to the term that came before it, right? A4 would be A3 plus 5. That's all this does, right? So not only do I have to give you the formula here, I also have to give you at least one term in the sequence. And they do. They say that A1 is 29. So I know A1 is 29, right? It says find the first 5 terms of the sequence. Well, if I want to find A2, according to my rule up here, I need to do the previous term, which would be A1 plus 5. Okay, that's all this rule means. That equation up there at the top, this right here, all it means is whatever term you're looking for is the previous term plus 5. All right, so when I do that, A2 would be 29 plus 5, which would be 34. All right, so 29, 34, I have A1 and A2. And then if I did A3, that would be A2 plus 5, which is 34 plus 5, which is 39. And once you get the pattern going, I don't need you to keep plugging in, right? Because we can add 5 repeatedly. We're smart individuals. So add 5 to this, you get 44. And add 5 to that, you get 49. There's the first 5 terms, okay? It says, now, from that, write the explicit formula. Well, it's arithmetic, so that would be a sub n equals a sub 1, which was 29, plus common difference is 5 times n minus 1. Boom. I can go from recursive to explicit just like that. Now, use that to find the 15th term. Either you have to do this 15 times, or now that we have the equation down here, I can do, okay, a sub 15 would be 29 plus 5 times 15 minus 1. Okay? And that'd be 5 times 14. And so all you got to do is very quickly do 5 times 14, all right, which is 70. All right, so that's a sub 15 equals 29 plus 70, which is 99. So there's your 15th term. This equation, I'm drawing an arrow to it as I'm talking. This one right here, the recursive, it cannot give you some random number in the sequence. It cannot do that. It can only give you the next term if you know the previous term. In other words, if you want to find A50 using this guy, you want to find A50, you must know A49, right? If you want the 50th term, you would have to know the 49th term, okay? If you don't, then the recursive formula doesn't make a whole lot of sense for finding large terms. It works very well for generating the first 5 terms in a sequence, right? Or the next 3 terms in a sequence. It does not do a good job of identifying a random term way down the road, right? Way down into the sequence, like a sub 15 or a sub 50, okay? The explicit formula, this one, is what you would want to use that for. It's important for you to understand what each one of these is used for, okay? All right, so next videos, we're going to talk about the exponential versions of these.